If you're interested to accelerate your Panda data frame operation, especially in the input pipeline to the transformer models from Hugging Face or your own coded artificial intelligence system, I can present to you today DASK. DASK is a very nice alternative for some parallelism on Python, and I would suppose let's jump right into it. I will restart the kernel, restart the kernel, clear all output, so we can start fresh. My Python version is 3.8.10. I import number, pandas, DASK, and PySpark, and I should be the latest version of DASK 2021-07. So what is DASK? I think it's answered best by the official documentation. DASK natively scales Python, and it provides some advanced parallelism for your data analytics tool. It is here that I want to show you on 3 topics. I'm going to show you some code on the performance on a numpy array. At first we have numpy on itself, and then parallelized with DASK, what speed improvements we can achieve, and we load a Panda data frame and a Panda data frame accelerated by DASK. The file size will be about 2 gigabytes, and you will see how fast DASK will provide some improvements. So we have larger than memory processing, and the first thing is, of course, to set up DASK. I choose here a local cluster. I am working on my Windows 10 machine at home. It's a PC. And as you see, with 4 lines of code, we have automatically set up DASK. At first, we have a scheduler and 4 workers. And as you can see here, I have a CPU with 6 cores and 12 threads. All 12 threads are now active. My total RAM memory is 64 gigabytes. System decided on 4 workers with 3 threads on each worker. And this utilizes my whole resources on my local PC. And we set up a local cluster. Now the next thing to do is very easy. We have to connect to this local cluster. We have a client, we have 12 threads, and we have 64 gigs of memory. So first example, a speed test. First, how much does DASK accelerate a numpy array operation? The first code segment here is a normal numpy random array. We do some exponential code, we sum up, and we time the operation. And then we import DASK for an array. You can see that the API of DASK is very similar to pandas. This is one of the great advantages. You have a very small learning curve because you are more or less already familiar with all the code sequences. And in the first case, the wall time here was 21.4 seconds for the operation in NumPy. And if we activate the DASK local cluster and do the operation on the local cluster, you see here our wall time reduced from 21 seconds to 4.31 seconds. So not bad at all. I have here 5 arguments, 3 pro and 2 con DASK. At first, of course, large data sets, and those data sets that do not fit in memory on a single machine, like for pandas. If you have some computation and you want to utilize all of your cores, all my CPU 12 threads I want to see at 100%, and I do not want to have 90% idle. And of course, you can have standard pandas operation in DASK like group by, join, and some time series computation. I will show you this example in a minute. If, on the other side, you have a dataset that fits comfortably in your RAM, then of course you should stick to pandas. And if you are have some functions, you're looking for some function, some functionality that is not implemented in the normal DASK data frame. Either you switch to another database, Postgres, or you have some task delayed, which offers more flexibility. But let's go into testing. And the first thing here after the numpy data array is now the panda data frame. And as you can see here on the right side, those 3 lines, we have the panda notation. We import pandas, we read a CSV file, we have some group by operation. And on the right side, we have the DASK data frame. The advantage now is that we can read multiple CSV files in, and we have the same notation for our code execution, with one exception, the compute command at the end, since we operated in a distributed system. Of course, we are not sticking to the CSV files. You can read in a package file. You can have all the different sorting and whatsoever operation going on. You have your group by commands. And when you are done of having this code execution in DASK, you can convert your result back to a panda data frame, and you continue working in the panda data frame as you were used to do. I already told you can load several CSV files with one command. This is all done. So let's create a DASK data frame. Easily done. You are familiar with all the notation. You can also have the maximum number of rows defined. You have your head commands, the first lines you want to see. And of course, if you want to know the number of rows of your data frame, 2.5 million, then you are familiar with the code sequences. So, and a speed test. We have here now a DASK data frame. We perform some operation, some group by, and we have a wall time from 67 milliseconds. Now we do the same with pandas. I have now converted to a panda data frame. This is my panda data frame. I do the same group by operation. And you can see instead of 67 milliseconds, it takes now 148 milliseconds. So very nice speed improvements applying some DASK on panda data frames. And finally, I want to show you a speed check concerning the upload speed. I have here a CSV file with a size of about 2 GB. It is exactly 1.738 GB. And I read this CSV file directly into my DASK data frame, wall time 12 milliseconds. To compute the size, it will take some time, but you will see that the content of this data frame is about 275 million elements. And now I perform a simple operation. I say my column named target. I want to count the most common words. And again, it is done in a very, very short time, 2 milliseconds. But the result that you get is that it's a DASK series object with integer 64. And if you really want to view this object, you have again to start compute. And then you can print out a presentation of the data frame. It's not a data frame, it's a panda series object, and it takes about 6 seconds to convert it. And here you have technology, data, systems, and those words appear 124,000 times in your DASK data frame. Now, if you compare this to pandas, you will see that in my particular case, the read-in, if you read the data file, it takes significantly longer. So here, just to upload the file, we have 12 milliseconds. And the normal panda operation for a 2 GB file is 20 seconds, of course. it still fits in memory. I have 64 gigabytes of memory and I read in a 2 gigabyte file, so no problem at all here. And if you perform here some value counts, the operation is done in, I guess, about 5 seconds, 5.8, let's say 6 seconds. Finally, if I'm working at home and I just have a laptop or my PC, my Windows 10 PC at home, I can finally utilize all 12 threads on my CPU when performing my Python operation. And the calculation for the input pipeline for my main task for all the different transformer models and the different application of artificial intelligence. Now the input pipeline significantly improves its time performance. And this is exactly what I am looking for in my particular case. So thank you for listening, and I see you next time.